today's lesson we are looking at difference of perfect squares. So if we remember that a perfect square is any number that is squared by itself, so multiplied by itself. So 3 squared is the same as 3 times 3. So if we look at difference of perfect squares, we're looking at two squared numbers being subtracted from each other. So we're going to look at 15 squared minus 12 squared. There are some people who are going to look at 15 minus 12. Well, that's 3, so this should equal 3 squared, which is 9. Let's have a look at that. We're going to use our area model to multiply this. So 10, 5, 10, and 5, 10, and 2, 10, and 2. So 10 times 10 is 100, 10 times 5 is 50, 10 times 5 is 50, and 5 times 5 is 25. We have 10 times 10 again, which is 100, 10 times 2, which is 20, 10 times 2 is 20, and 2 times 2 is 4. And if we add up all these numbers, 100 plus 50 plus 50 plus 25 equals 225. So 15 squared equals 225. Let's rewrite that. And we know that 12 squared, which is 12 times 12, 100 plus 20 plus 20 plus 4 is 124. Sorry, 144. And we can clearly see that the difference between those two numbers is not 9. It's actually quite considerably more at 81. So that is not the same as that. So let's actually investigate this further. But to do this a little bit more, we actually need to look at the algebraic side of this. I'm going to go back a step and look at expanding binomial brackets. So let's look at x plus 3 and x minus 3. So we'll look at that. Using our area model, we have x plus 3, x minus 3. So x times x is x squared, x times 3 is 3x, x times negative 3 is negative 3x, and negative 3 times 3 is negative 9. So if we look at some of these terms, sorry, I've grabbed the wrong colour there. If we look at some of our terms, we'll see that those two terms actually cancel each other out. So we're left with, from that, x squared plus 3x minus 3x minus 9. Well, 3x minus 3x, they'll cancel each other out because that's 0. So we are just left with x squared minus 9. And we know that 9 is actually the square of 3 squared. So we could write this as x squared minus 3 squared. So we're now actually back to our original question on the previous slide. We have a difference of perfect squares. Let's try this for another number and see if it works as well. Let's use x plus 5, x minus 5, and let's see if we get the same result. Put our x's in, plus 5, minus 5, x squared, 5x, x, negative 5x, and negative 25. Well, we can already see we're going to get the same result because our 5x and negative 5x are going to cancel each other out. X squared plus 5x minus 5x minus 25. Now, 5x's cancel, and we are just left with x squared minus 25, or x squared minus 5 squared. So we're back to our difference of perfect squares. But what we actually want to look at today isn't expanding these. We actually want to factorize it. So we want to go the other way. So we want to look at x squared minus 4. Well, 4 is the square number of 2. So we actually have x squared minus 2 squared. So what does this look like using our area model? So we have x squared in there and we have negative 4 in there. So these two terms need to be something that will cancel each other out. And because we know that the square root of 4 is 2, or the square of 2 is 4, we have our x's here. And we know that negative 2 times 2 is negative 4. So we have a 2 here, a negative 2 there. Negative 2 times x is negative 2x. 2 times x is 2x. And we still come back to our same point of before. Our 2x and our negative 2x cancel each other out. So our factors of x squared minus 4, x plus 2, x minus 2. And that rule actually works every single time. But we'll do a couple more and then we'll look at that special rule. So x squared minus 16. So we want a number, the square root of x squared, which is x. And we want the square root of 16. We know that 4 times 4 is 16. So negative 4 times 4 has to be 16, negative 16. So these are actually going to be our factors. X squared, 4x, negative 4x, negative 16. So multiplying all that out, that works. Our 4x, our negative 4x cancel out. So there is one factor. There is our other factor. So we have x plus 4, x minus 4. So let's generalize a little bit more and not use some numbers, but use another variable. So let's use the terms a and b. So we know that a squared minus b squared. So we have b and negative b. A squared negative b squared, a b minus a b. Our two ab's cancel out because one of them is negative. So it's having some pen issues. So we're left with our original expression of a squared minus b squared. So our factors are a plus b, a minus b. So in a nutshell, we can say that if we have a squared minus b squared in an expression, it will every single time factorize out to a plus b, a minus b. So I hope this is helpful. Hope you continue reading through the notes and the exercises in our OneNote.